Right? Okay, you split into two directions, AN, F equal to MA, two direction. We do the normal direction first. So normal, you have forces, normal, and your weight. Remember the positive, negative sign. Normal is pointing up to the center of the curve, equal to MA. This one is in normal direction. Again, NA equal to V square over rho. Since the rho is not given, you need to find. There's an equation to find this rho. Okay. And there's a reason why we do integration, differentiation just now. Okay, so you substitute the value and you find the AT. So there's no tangent direction force. Okay. And 70 AT. Right? So you have two equations. Your AT is 0. NA equals something. V square over rho. Okay. Recall, this equation won't be given, the purple color equation. It won't be given in the test. We assume you already know. So don't memorize wrong. It's bracket, then 3 over 2. Means you square root and then you multiply 3 times. Okay. So we already do the integration just now. 2 times is 1 over 30. Substitute here. Press calculator. You find your rho. Okay. Your rho will be 30 meter. So substitute back into the equation. Okay. So this is the diagram lah. So 30. You do substitution. You find what is your NA. Okay. You substitute here. You find your NA. So once you have your NA, you go to your kinetic diagram. You can find your acceleration is normal condition, normal direction. Then you find resultant. You find resultant, square AN, square AT, square root. You find is 13.3 meter per second square. Going up. Why I know is going up? Why I know it's not going up and it's not going to another angle? Why? What is the value of your AT? 0. There's no vector here. You only have one vector. So you know that your resultant will follow one of the vector. In this case, AN. Okay. Okay, so it asks you what is the acceleration at this point. Okay. Okay. So the next is in cylindrical coordinate. This one I rarely ask you, but if you go further, if you did your masters or your FYP projects, then you might consider 3-dimensional. So if it's cylindrical, then you deal with angle and so all this. So same equation, F equal to MA, but is in radian, theta, and z direction. Okay. So you still solve in three axes. Normally we deal with x, y, z or normal tangent, but when it's in cylindrical, then you have theta, r, and z direction. Okay. Okay. So when did you use the equation for cylindrical coordinates? So I give you two examples, right? So this one I go very fast. We go example 7. And when you know that you need to use cylindrical, you look at the question, you know already. You are given angle, you're given theta dot, you're given r and cos. Then you know that this is chapter 2. You need to use the polar coordinate system. So you're given a smooth collar here, slide along AB. So it means that if you move this rod here, you move rod AB, this collar C will slide along these cylindrical bodies. The radius is 0.4. Okay, and the changes of this length is 0.8 cos theta, theta by this from the horizontal to the rod. The angle of rotation is given in blue color arrow, is anticlockwise. Constant angular velocity, 3 radian per second, determine force exerted on the collar at the instant 45 degree. Okay, so same. Okay, don't panic. When you see the one, don't panic. First, draw free body diagram, or you can write F equal to ma, or the force equal to ma. And since this one is in angular, so you do in the angular form. So you draw the collar, you copy the collar, and this is a circular motion. You look at the motion, it's circular. So circular, you have normal and tangent direction. Okay, so if you see a linear means xy. You see circular, straight away go to normal tangent. So normal go inside, tangent go this way, right? Okay. Then you have a radial direction and angle direction. Radial means the radius go out positive, so means R go out this way and theta going this way because of the rotation angle. Okay. Then you start with the normal contact of the guide, which is go down at the tangent direction. Then there's a force pushing. There must be a force pushing this rod so that this one can rotate. So where is the force? The force will go through the center of the mass, and we label it as AB. Okay. Then you continue with that. So you have done with all the force. Why there is no weight inside here? Okay. So in a radial or radial coordinate, you deal with R and theta. Fr equal to ma r. So in R direction, this one in R direction, so there's an angle. So NC cos theta. So in R direction, so this one can split this way and this way, this way and this way. So your R is go up positive, but if you split NC, you pointing opposite of your R. So that's why you get negative. And M is given 0.5 and R. So theta also same. Theta is this direction. So FAV positive, NC same. You split this way. So it's go against the theta, so negative. So we have two equations. You solve the equation. Okay. So again, this one you go home and do some homework. So R equal to 0.8. You differentiate, you get this one. How to get this one? You use chain rules, and you still haven't access to Canvas. Please go to appendix, download Appendix C and read the chain rules. You need chain rules in your finals. Okay. So you arrive at that one. You substitute the angle. You substitute angle there, and theta dot is given. And you differentiate one more time. This is the constant value. Double dot is 0. This is constant value. You differentiate with time, you get 0. So once you get 0, you can cancel, right? Sine 0 equal to 0. Cos 0, 1. Okay. Okay, go and substitute. You get your R and R theta. Recall chapter 1. Your AR and A theta. There's an equation there. This one also need to memorize. Okay. Derivation step also inside the slides already. So go home and flip to the chapter 1, radial coordinate. So from there you get your NC, your answer. Same with example 8. Go home and read. This one is your homework. Go home and read. All the answer is there. Okay, with this we conclude chapter 2. Okay, this Wednesday, those group that you haven't finished, please continue your lab. And for your info,